Hello everyone, welcome to my channel. This is 𝐩𝐢𝐭𝐇𝐮 and in today's video I'll explain you how we can automate deploying Flask application on AWS EC2 using GitHub Actions. So here you can see this is the current repository I'm using for this Flask application automation. So let me explain you about this repository. So let me open this app.py file. So basically it will display a small message like hello everyone, happy learning. Okay, basically it will run on the port 5000. So now let me open this Docker file. So basically we are going to package this Flask application using Docker. So in this Docker file, basically we are going to take base image as Python 3.13 slim, and next we are going to set this working directory as /app, and we are going to copy this requirements.txt and app.py file, and we are going to install few of the dependencies, and next we are going to expose this Flask application on port 5000, and we are going to run this Flask app. Okay, so this is about the Docker file. So normally when you make any changes to this Flask app, you manually need to build Docker image. Next you need to store that Docker image on your DockerHub. Next we need to log into AWS EC2 and we need to pull latest Docker image, and using the Docker image we need to restart the Docker container, right? That's a lot of steps and it's easy to make mistakes. So to avoid this manual work, now we are going to create a GitHub Actions CI/CD pipeline to automate all of this for us. Now every time when you push latest code to this GitHub, it builds the Docker image, scans it for security issues using Trivy, and next it automatically deploys it to AWS EC2, and it's an hands-free deployment, guys, basically. Okay, so now let's create GitHub Actions pipeline. So before creating GitHub Actions pipeline, initially first I'm going to create an EC2 instance. So I'm going to use that EC2 instance as my self-hosted runner. Okay, so let me jump onto my AWS management console. So currently I'm on Mumbai region. Let me check VPCs on Mumbai region. Let me select here your VPCs. So currently I have test VPC. So let me check any subnets are available or not. Resource map. So I have one subnet. So this is fine. Okay. So let me open EC2 and directly select launch instance. So I'm going to use this EC2 instance as a self-hosted runner, guys. Okay. So directly I'm going to select here launch instance, and instance name. Let me provide name like GitHub Actions runner. Okay, so let's provide the name like this, and OS I'm going to select as Ubuntu, and I'm going with 24.04. Now instance type I'm going with T2 medium. Let's go with this. Okay, and key pair. So let me create a new key pair. So I think already have a key pair with name GitHub runner key pair. So let me check this in my local. No, I don't have in my local. So let me create a new key pair. Actions key pair. Okay, so let me provide a name like this, and format I'm going with .pem and create key pair. So a private key has been downloaded to our local computer, guys. Okay, so now under networking settings, here I'm going to select this test VPC, and here I'm going to select this test subnet and auto assign public IP address. So here you need to keep this in enable mode, guys, because in order to provide public IP to your EC2 instance, you need to provide this enable this, guys. Okay, in security groups, I'm going to create a new security group, GitHub Actions SG, GitHub Action security group. So let me copy this and let me remove this description and let me paste it this. Now, right now I'm going to provide only SSH access, and or else you can directly provide HTTP. Okay. So HTTP is not required. For now, SSH is enough, guys. Okay. So I'm going with 10 GB and directly select your launch instance. So you can go with 8 GB also. That is not an issue, guys. Okay. So directly select here instances. Our instance is in currently pending state. So let's wait for some time. So meanwhile, let me create a GitHub Actions pipeline. Let me create a single job. So basically, when you are creating any of the GitHub Actions pipeline, you need to create in this path. So okay, so you need to create .github/workflows. So inside this, you can create with any of the names. So currently, I have created with deploy.yaml, guys. Okay, so let me open this. So currently, I have removed this entire code. So let's write this everything from scratch. So Let me open this Notion. So here you can see this is the entire GitHub Actions pipeline currently we are going to use. So basically I have written this pipeline earlier, guys. Okay. So let me copy this first job and let me come here and let me edit this and let me paste it here. Okay. So basically for this pipeline I'm going to provide name as CI/CD pipeline. So here you can see on push branch, so whenever any changes are happened in this main branch, it will start this GitHub Actions pipeline, guys. Okay. So for now I have given only main branch. So in future I will explain you how we can work with multiple branches. Okay. So here you can see this is the first job. So in the first job it will pull this entire code from this repository. Okay. So here you can see this is the name checkout we are going to provide. So name of this job we are going to check out and set up. So let me remove this, and here you can see runs on self-hosted. Okay. So it will run on this self-hosted EC2 instance. So basically we are going to use this EC2 instance as a self-hosted runner, right? So we are going to install runner on this EC2 instance. Okay. So it will take the code from this repository. That's it, guys. Okay. So meanwhile, let me commit these changes. So it will not work, guys. Basically, let me select here actions and let me select this and let me open this first job. And here you can see basically labels we have given here self-hosted. Okay. So currently it is waiting for a runner to pick up this job. Okay. So currently we haven't set up any of the runner. So first let's connect to this EC2 instance and let's set up a runner on the EC2 instance. Okay. So let me copy this and let me open here MoboXterm. So here you can use MoboXterm putty or it may be anything. So directly select here session and SSH, and here you need to provide your public IP address of your EC2 instance, and here username I'm going to provide as Ubuntu, and in advanced SSH settings, and here we need to provide the path of the private key. So let me provide this path of the private key and directly select here OK. So here you can see successfully it is connected to this EC2 instance. So now let me update this instance. Sudo apt update -y. Okay. So always you need to update your EC2 instance, guys. Okay. So here you can see it is updated successfully. So let me open this. Let me come here. And now we are going to set up a self-hosted runner. So this is our repository, right? So inside this repository, so let's wait. Okay. So this is our repository. Inside this, you need to open this repository settings. And now here you need to select here actions. And here you need to select runners. Okay. Now here you need to select new self-hosted runner. And right now I'm going to install this on Linux environment because we created Ubuntu EC2 instance, right? So here we need to select Linux. If you want to perform this on Windows, you can directly select here Windows, or else if you want to perform this on Mac OS, you can directly select here Mac OS. Okay, there will be different commands. So now I'm going to select as Linux, and architecture I'm going with 64. Now first we need to initially create a repository. So directly copy this. You can directly copy all these commands, guys. Okay. So you need to open your MoboXterm and you need to paste it here, enter. So here you can see first initially it will create a directory called actions-runner, and after that it will enter into this actions-runner directory. Okay. So now let me open this, and now we are going to download latest runner packages. So you need to copy this, you need to open MoboXterm and you need to paste it here. Okay. And let me hit ls. So here you can see it is downloaded. So now let's validate this hash. Let me paste it here, hit enter. So here now we need to see OK. So here you can see it is validated. So now let me extract this installer. So now basically we are going to extract this, guys. Okay. So paste it here and enter. So let me hit ls. So here you can see it is extracted successfully. So now let me copy this. So now we are going to create and start the runner configuration. Okay, so let me copy this and let me open this and let me paste it here. So here you can see GitHub Actions self-hosted runner registration. So I'm not going to provide any of the names in particularly in this video. Okay, so in future videos I will explain you all this. So directly hit enter, and tags I'm going with self-hosted. Okay, hit enter. So here you can see label I'm going to use a self-hosted, guys. Okay, so here you can see runner successfully added. So enter name of the work folder, you can directly hit enter, that is not an issue. Okay, so here you can see settings saved. So now let me check on this EC2 GitHub whether it is added a runner or not. You can directly select here settings and directly select here actions and directly select here runners. So here you can see a runner has been added. So these are the labels, which is self-hosted, Linux and x64, guys. So we haven't particularly given any of the labels. So we're going to use this default labels itself. Okay, so this is our EC2 instance private IP address, guys. Okay, 10.0.4.211, right? So here you can see this is our EC2 instance and this is the private IPv4 address of our EC2 instance, which is 10.0.4.211. Okay, so now let me open this. So currently there are no jobs running. Okay, so now I'm going to use this tag which is self-hosted. Okay, let me open this. So let me open this. Okay, so for this labels already we have given self-hosted, right? But still this is not running. Why? Because means let me open this GitHub settings and directly under actions you need to select your runners and you need to start this runner, guys, basically. Okay, let me open this. You need to start this runner. Okay, /run.sh. So here you can see connected to GitHub. So currently it is listening for jobs. Now here you can see our job is running job, checkout and setup. So automatically this job is running now. Let me select your actions and here you can see our job is running. So here you can see our job is also green. Okay, so let me drop down this. So here you can see it has taken entire source code from this repository, guys. Okay, so this is the first job. So now let's create a second job. So let me select here Flask actions repository. So now you need to always go to this .github/workflows directory and let me open this deploy.ml file. So basically it has taken the source code in the first job. So now let me create a second job. So directly select here edit. Now let me open this Notion page. So up to here, this is the second job. Okay. So let me copy this and let me paste it here. Okay. So basically, it's a second job. So for this, we have given a job like build, and name of this job we are going to provide as build and push image and runs on self-hosted. Okay, so we are going to run this job inside this EC2 instance. Okay, so basically we are going to use this EC2 instance as a self-hosted runner. So for this labels already we have self-hosted, right? So that's why here I'm going with self-hosted. So if you are providing some other labels, you can directly provide that. Okay, so here you can see needs, that means checkout. That means here you can see this is the first job, checkout. So after completing this job, it will run this second job, guys. Okay, so this is how it works. So this is the steps. So first it will take the code. Next it will log into our Docker Hub, guys. Okay, so here you need to provide your Docker Hub token and you need to provide Docker Hub username. So here I'm not providing a Docker Hub password. Here instead of Docker Hub password, I'm providing Docker Hub token, guys. Okay, so now let's provide this Docker Hub username as well as token. So meanwhile, let me comment this second job. Let me comment this and let me select here commit changes. And now you need to select your Flask app actions and here you need to select settings. And now here you can see, sorry, secrets and variable side. So you need to drop down this under here. You need to select here actions. So I think already have my credentials. So let me delete this. Let me create this everything from scratch. So just a second, guys. Okay, I have approved this. Now let me delete this Docker Hub token as well. Okay, so here you can see under settings, you need to select here secrets and variables, and there you need to select here actions. So inside this, right now I deleted my Docker Hub username and token. So now I'm going to store that Docker Hub username and Docker Hub token on this GitHub secrets, guys. Okay, so if you want to store as a variables, you can directly select here variables, and you can directly provide that variables, or else if you want to secure that username and password, you can directly go with secret. So I'm going with secrets. So here I'm going to create new repository secret. So here we need to give the secret name. So let me open this. So secret name is Docker Hub token. So this is the secret. So let me paste it here. So here we need to create a Docker Hub token, and you need to provide that Docker Hub token here in order to log into our Docker Hub. So let me open here Docker Hub login. Let me open this first link. Directly select here sign in. So here you can see I just log into my Docker Hub account. So now let's create a token for this GitHub Actions. Okay. So you need to select here your profile, and here you need to select account settings, and here you can see personal access tokens. So you can directly open this. So from here we need to generate a token. So directly generate a new token. So let me provide a name like GitHub Actions -CI. Okay. So here access I'm going to provide read, write, and delete. Okay. So directly select here generate. So now here you can see a token has been generated. So now this is the token. You need to copy this token, and you need to open your GitHub account. So let me open that GitHub account. So this is the one. Okay. So you need to paste that token here. Okay. So it will act like as a Docker Hub password, guys. Okay. So you can directly select here add secret. Oh, so now we added secret successfully. So now we need to add this Docker Hub password. So you can directly copy this variable, copy this, and you need to come to GitHub and directly select here a new repository secret, and name of the secret. We need to provide this Docker Hub username, and my Docker Hub username is 𝐁𝐢𝐿. Okay. So directly select here add secret. Now, using this Docker Hub username and Docker Hub token, it will log into our Docker Hub account, guys. Okay. So let me select here Flask app actions, and let me open this workflows. Let me open this deploy.yaml. So now let me uncomment this. Okay. So now let me explain you about this second job. So basically here you can see uh, this is the job. Okay. So name we are going to provide as build and push image. So it always runs on self-hosted runner. That means it will use our EC2 instance as a self-hosted runner. And here you can see needs checkout. That means after completing this checkout job, it will start executing this second job. Okay. So these are the steps. So first it will take the code, and next it will log into our Docker Hub using this Docker Hub token. So Docker Hub token will act like as a Docker Hub password, and it will use this Docker Hub username to log into this Docker Hub. Next, it will build a Docker image. So here you can see it will build Docker image like Docker build -t. Username it will take as 𝐁𝐢𝐿 slash flashcap slash, and it will take git sha. Always it will tag with latest git sha, guys. Okay. So that means it will always tag with latest commit ID, and dot refers to Docker file. So our Docker file is in this local path only, right? So using this Docker file, it will build this Flask app Docker image. Next, it will tag this Docker image using latest tag. Okay. So as well as with git sha commit id. Okay, so it will tag two images, one is git sha as well as with latest tag. So next, let's come down. It will push both the Docker images to DockerHub. Okay, so here you can see Docker push 𝐁𝐢𝐭𝐇𝐮 slash flash cap colon git sha. That means commit ID. So as well as flash cap colon latest, it will push both the Docker images to DockerHub. Okay, so using this DockerHub token and DockerHub username. So now let me select here commit changes. In commit changes, directly select here actions. So open this and let me open this checkout. So here you can see it is taking the source code. So let me open this parallelly. So here you can see currently this job is running, right? Checkout and setup. Okay, so it's completed. So now it's running second job, build and push image. So now let me open this. So here you can see build and push image. Every job you can see inside that EC2 instance, guys. Okay, so here you can see our job is failed. So let me check why it's failed. Let me open this. Okay, so here you can see command not found, docker not found, guys, basically. Okay, so basically we are going to use this self-hosted runner, right? So in order so you need to install docker in this EC2 instance. So let me open this in a new tab. So now let's hit here sudo su. Now currently we are on root user. Now let me install docker in this, guys. Okay, sudo apt install docker.io slash hyphen y. Okay, so now it will install docker. So why this job is failed means docker is currently not installed in this self-hosted runner, guys. Okay, so everything we need to install in this self-hosted runner. So that's why this second job it is failed. Okay, so now systemctl enable docker, and let me provide executable permissions chmod 777 slash var run, and here docker.choc. Now systemctl status docker, we need to see this at1 running. So now it's at1 running. Now let me hit docker version. So here you can see this is the version 27.5.1. Okay, so now let's come here. Now let's try to rerun that pipeline. So you can directly run only failed jobs, guys. Okay, so here you can see rerun jobs, and if you want to run all the jobs you can directly select here rerun all jobs, or else if you want to run only failed jobs you can directly select here rerun failed jobs. Okay, so this is the one of the main advantage of using GitHub Actions. So you cannot find this option on even Jenkins, guys. Okay, so you can directly select here rerun failed jobs. So currently I'm going to run only failed jobs. So I'm going to select rerun failed jobs and rerun failed jobs. So now here again it will start one another job, guys. Here you can see running job build and push image. So now let me select this second job, and here you can see now it is successfully log into our Docker Hub, and currently it is trying to build Docker image. So here you can see now it is working because earlier we haven't installed Docker. So now we install Docker, guys. Okay, so let's wait. Currently it is building Docker image. So now it is going to tag our Docker image using git sha, that means git commit id, and currently it is push our docker image. So let's wait, and here you can see our job is green. So here you can see success. Here you can see our job is also completed. Okay, so every time when you run any of the job, here it will trigger that job, guys. In EC2 instance also you can see that jobs. Okay, so now our build is green. So now let's check in our Docker Hub. Let me open this and let me select this icon, Docker icon, and directly select here hub and repositories. So here you can see just 1 minute ago. Let me open this 𝐁𝐢𝐭𝐇𝐮 slash Flask app. So here you can see it has pushed two different Docker images. One is latest tag Docker image and one is git sha. Okay, so this is the commit ID, git commit ID, guys. Okay, so let me open this. So this is the image. Okay, Let me go back. So both the images are successfully pushed to this Docker Hub. So now let's create a third stage. That means third job, which is Trivy. So let me copy this from here. Sorry. Let me copy this and let me open this GitHub Actions and let me directly select here Flask Actions and let me open this .github/workflows directory, and inside this you need to open this deploy.ml and let me edit this. Now inside this is the third one, right? Let me paste it here. Okay. So this is the third job. So for this name, we are going to provide a security scan with Trivy, and it runs on self-hosted runner. That means it will run on this EC2 instance. So we are going to use this EC2 instance as a self-hosted runner, right? So it will run this job on that self-hosted runner, and here needs build. That means after completing this build job, it will start executing this third job, which is scan. Okay. So these are the steps. First, we are going to install Trivy. So I was just installing Trivy from this pipeline itself. Okay. So if you want to get all these commands, you can directly go to Trivy official documentations. You can directly search for install Trivy on Ubuntu, and you can directly open this first link. So here you can see Debian and Ubuntu. So I just copied all these commands from this official documentations and I just provided it here. Okay. So first it will install Trivy for the very first time. So next it will scan our latest Docker image. So here you can see Trivy image --exit-code 0 -cvrt. It will display high-end critical severities and it will scan our latest Docker image. So if it found any critical vulnerabilities, it will display message like critical vulnerabilities found. Okay. So then you can check that vulnerabilities. Okay. So now let's try to run this third job. Let me directly select here commit changes and commit changes. So now automatically here new job will start, guys. Okay. So let's see. So here you can see running job, checkout and setup. Okay. So this is the very first job. So let me select here actions. Let me open this, and here you can see this is the first job. So first job is completed. So second one it's running. So currently it is waiting for. So here you can see it is provided. So here you can see running job build and push image. So this is the second job. So currently again it is trying to build the Docker image. It will tag the Docker image with git commit ID as well as with the latest tag, and it will push the Docker images to Docker Hub. Okay. So this is the stage for that. So it's completed. So now it's Trivy. So it's searching for labels self-hosted. It is assigned successfully. So currently it is trying to install Trivy in our EC2 instance, guys. Okay. So after installing Trivy, it will scan our latest Docker image. So here you can see right now it is scanning our latest Docker image. Okay. So installation is completed. So it's generating a small report. So its words failed. So let's check this. Let me open this Flask actions and let me open this .github/workflows and let me open this deploy.ml and let me check. So here you can see this is the issue, guys. Okay. So let me edit this. So it's not in a proper format. So let me copy this flash cap colon latest. So let me provide it here. Okay. So now it needs to work. Let me open this and let me select here commit changes and commit changes. Okay. So now again this job will start running this entire build. So currently it is taking the code. So here you can see, let me open this. So first job it is running and it's green. Now it will start second job. So here you can see second job build and push, it's running. Let me open this. So currently it is trying to build the Docker image, and after that it will tag the Docker image with the latest Git commit, and as well as with latest tag, and it will push both the Docker image to DockerHub. Okay. So this is the third one, security scan with Trivy. So currently it is trying to install Trivy, so it's installed successful. So now again it got failed. So let me do one thing. Let me open this Flask app actions and let me open this .github/workflows and let me open this deploy.ml. So let me edit this. So here what I will do is like, so let me come down. Let me pull this image, guys. Okay. Name pull image, and I'm going to provide this command. Let me open this and let me pull this image first from this Docker Hub. Okay. So let's test like this. Okay, it will pull and it will scan this latest Docker image. So let's check whether it will work or not. Commit changes and commit changes. But when I worked earlier, it works fine, but now it's not working. So let's see actions. Open this up. So every job it will run in this self-hosted pipeline. Okay, sorry, self-hosted runner. So here you can see currently it is going build and push image. So currently it is trying to push our Docker image to Docker Hub. And security scan with Trivy. And it got failed. So let me do one thing. Let me open this Flask app actions and .github/workflows, and you need to open deploy.ml, and let me read this, and I'm going to remove this. So let me remove this. Let me try to run this now. Commit changes and commit changes. Directly select actions and update deploy.ml. So currently it is taking the code. So here you can see build and push image. So currently now it will build the Docker image. So first initially it will log into Docker Hub. It will build the Docker image. It will tag the Docker image with the latest GitHub SHA, and next it will tag with the latest tag, and it will push both the Docker images to Docker Hub, guys. Okay. So this second job it is completed. Now security scan with Trivy. So now let's see whether it will work or not. So now here you can see currently it is working fine and our job is also green, guys. Okay. So there is a small typo, so that's why it's not worked. So here you can see Trivy has generated a detailed report. So now this third job also it is green. So now let's quickly copy this fourth job. Let me copy this and let me open this. So meanwhile, let me show you this Trivy, whether it is installed on this EC2 instance or not. So basically we install this Trivy from the CI/CD pipeline itself only, right? So you can directly open this. Now hit Trivy hyphen version. Okay. So here you can see Trivy has been installed successfully. Okay. So you can directly install from pipeline itself, although that is also not an issue. Okay. So let me select here Flask app actions and directly select here .github/workflows and open this deploy.ml and directly edit this, and this is the final job, guys. Okay, so let me hit enter and let me paste it here. Okay, so here you can see for this name we are going to provide as deploy on EC2. So we are going to run this job on self-hosted runner and need scan. That means after completing this scan job, it will start executing this job. Okay, so steps. So name we are going to provide as deploy latest container. So first it will check for this sorry, first it will stop this Flask app container, and after that it will remove this Flask app container. So basically we are not going to run any of the Docker containers. Here you can see Docker PS and Docker PS hyphen A. We don't have even a single stopped container. Okay, so first it will stop the Flask app container and it will remove the container. For the first time it will fail, guys. Okay, so after that it will sleep for 6 seconds. Next it will pull the Docker image. That means Flask app colon latest Docker image. So let me open this and let me select here repositories. So let me open this. So it will pull this latest Docker image from this DockerHub. Okay, so let me open this, and after that using that latest Docker image it will run Docker container inside our EC2 instance. So this is the command docker run -d -name Flask app. So this is the name of the container and -p. So we are going to provide localhost port as 5000, and our container is also running on port 5000, and this is the image /git3/flask app colon latest, guys. Okay, so we are going to always this CI/CD pipeline will always deploy latest image to this container, guys. Okay, so after that again it will sleep for 6 seconds and it will do docker system prune. That means it will remove unwanted docker images, volumes, whatever it may be. It will remove unwanted things. Okay, so let me remove this final command and let me select here commit changes. Okay, so before selecting here commit changes, so once again I'm showing you here. You can see currently we don't have single docker container, and even stop docker containers we don't have, right? So let me select here commit changes and commit changes. So now select actions. So here you can see a job has been started. So currently it is in checkout. So you can check here also. So let me open this first step. So here you can see currently it is checkout. Checkout is green. So now it will start second job. So here you can see job running build and push image. So here you can see currently it is trying to push Docker image. Image has been built successfully. So now here you can see. So this is the third job. So here you can see running job security scan with Trivy. So now Trivy will scan our latest Docker image, guys. Okay. So here you can see Trivy is generated a report for us. And this is the final job, which is deploy on EC2. So currently now it is trying to deploy our application to EC2 instance. So here you can see uh, Docker stop Flask app. So currently we don't have even single Flask app container, right? So that's why it is showing like response from daemon, no such container. So currently it is pulled the Docker image and it is successfully run the Docker image using our latest Docker image. And here you can see our job is also completed. This pipeline is green. So let me open this. So here you can see deploy on EC2 complete. Okay. So now let me check this whether it is completed or not. Let me open the second tab. Now Docker PS. So here you can see from last 36 seconds our Docker container is running. Okay. So this is how the CI/CD pipeline will deploy. So now let's try to access our application. So we need to provide this port 5000 on our security groups first. So let me open this EC2. Directly jump onto security. Directly open this security group. So currently we have only port 80 and 22, right? So now we need to provide our Flask app container port, which is port 5000, guys. Okay. So you need to come here, edit inbound rules, add rule, and which is custom TCP, and port you need to provide as port 5000. And here you need to provide anywhere from IPv4 and directly select your save rules. So now let's try to access our Flask app application. So you can directly select here details and copy public IPv4 address, open a new tab and here http colon slash slash, and you need to provide public IPv4 address with port 5000. Hit enter. So here you can see, hello everyone, happy learning. Okay. So now let's open this Flask app actions. So let me open this app.py. So here you can see currently it is displaying this hello everyone, happy learning, right? So now let me try to edit this. So before editing this, I want to show you one another thing, guys. Okay. So if you are trying to uh, cancel this job, that means if you are trying to cancel this script, it will not run this pipeline, guys. Okay. So let me select your actions and let me open this latest build and let me before rerunning this, let me stop this script. So here you can see now we are not going to run this runner. So now if I try to run these jobs, now it will not work, guys. Okay. So here you can see currently job is not running. Okay. So let me open this. So here you can see requested labels self-hosted. So here you can see job is about to start running on the runner. Okay, so this is our instance private IP address. Okay, so currently here you can see it is not working. Why? Because means we are not running this script. Always in order to work this CI/CD pipeline, you need to run this script's background, guys. Okay, so you need to run this run.sh file. So now here you can see when I hit run.sh, now it will connect to this GitHub. Now here you can see listening for jobs. Now it will work. So here you can see automatically now it will work. So here you can successfully it is connected. Okay, and now here you can see running job checkout and setup. Okay, so this is how it works, guys. Always you need to run this script in background, which is dot slash run.sh. You need to run this run.sh file always. Okay, so here you can see second job it is running. So this is the second job. So after completing this job also it will display the same message because we haven't modified in GitHub repository. So after this pipeline is green, let's modify that app.py file. Okay, and let's see whether it is reflecting the latest code or not. Currently it is going security scan with Trivy, and here you can see deploy on EC2. So this is the final stage. So before this, let me come here. So currently here you can see Docker PS. From last 4 minutes, it is running this Docker container, right? So now here you can see it is stopped the old Docker container, which is Flask app. And here you can see it is pulled latest Docker image and it is successfully running the latest Docker container with the latest Docker image. Now here you can see our job is also completed and our job is green. So now let me hit again Docker PS. So here you can see from last 16 seconds, new Docker container is running, guys. Okay. So, but here it will not change anything because we haven't modified anything in our GitHub repository. So now I'm going to modify in my GitHub repository. Let me select here Flask app actions and directly open this app.py file and let me edit this. And now here you can see I'm going to modify this to hello everyone from GitHub actions. Okay. So now I'm going to modify like this. I'm going to add this only from GitHub Actions. Okay. So I'm going to select here commit changes and commit changes. So currently here you can see it is displaying only. If I refresh this, it is displaying only hello everyone, happy learning. So now let me select here actions and let me open this job. So here you can see currently it is taking the code. So first job it is completed. Now currently it is building the Docker image. So here you can see it is logged to our Docker Hub. Now it is building the Docker image. Now currently it is trying to push our both Docker images, latest Docker images as well as Git share Docker image. It is trying to push to Docker Hub. So here you can see it is showing pushed. So let's wait. Now this is the third job, which is security scan with Trivy. So now Trivy will scan our latest Docker image for any of the vulnerabilities. So here you can see Trivy has generated a report for us. So this job is also completed. So now this is the final job. So initially first it will stop the running containers, which is Flask app containers. So here you can see this is the Flask app container. So currently it is stopped. So now it will pull latest Docker container from DockerHub. So here you can see it is pull latest Docker image, and it will using this image it has successfully run this Docker container, and finally it will do system prune. Okay, so here you can see our job is green. So now let's come here. So here you can see currently it is showing hello everyone, happy learning, right? So if I refresh this, so here you can see hello everyone from GitHub Actions, happy learning. Okay, so now let me come here and let me hit Docker PS. So here you can see from last 28 seconds new Docker container is running. So this is the content it is displaying. Okay, so this is how it works, guys. So now whenever any changes are happened in your source code, automatically this GitHub Actions pipeline will come to action, and it will deploy latest changes to this EC2 instance, guys. Okay, so this is the complete pipeline. So, and yes, that's it for today's video. So in next video I will come with a good project on GitHub Actions pipeline, where we are going to deploy a sample application on GKE cluster. So there we are not going to use this self-hosted runner. Instead of self-hosted runner, we are going to use GitHub Actions images. Okay. So, and yes, that's it for today's video. And after completing your labs and everything, just try to delete your EC2 instance. Okay, so that will be enough. So, and yes, that's it for today's video. And if you like my video, please do like, share, and subscribe to my YouTube channel, guys. And see you in the next video. And bye.